And this is the of this our syllabus, content of the syllabus. Practical there, packet sniffing using ethereal or any other tools, and practical on the cracking tools, John cracks or the loop text, loop cracks, and practical on the denial of services, IP spoofing and all, and vulnerability assessment tools, and mapped, and practical on the FTP and telnet hacking and all, and in system security that practical on the OS fingerprint using this and using this nmap, installation of security, configuration of email servers like sendmail, practicals using this administrator of and get TCP dump and so on, that configuration of the web server and all, and it's included the practical sessions also here, but I don't know whether we can do the practical or not in this session. And under this cryptography and network security, we have to do this system algorithm analysis using these crypto tools, asymmetric algorithm analysis using these crypto tools, hash algorithms using these crypto tools and all. And here wireless also there, wireless LAN installation. We have to do some Kali Linux also there. And under this one, project and advanced security are theirs, problem definitions and architecture development and requirement analysis, security server selections, configuring server, final design deployment phase and testing phase. Okay, so these are the point in this uh, this syllabus, and students can select any tools, software and hardware for the project developments and test system. So we can do it or not, I'm sure, this project due to this pandemic and all. Let's see whether we can do it or not. So project also comes under this syllabus. Okay, so the syllabus is very vast and very difficult to understand maybe for the entry level, but anyway we have to tried to complete the syllabus. Okay, and MCA 6 semester ni lozong fourth semester lam tu nahan fourth la 15 ni tro fourth la 6 tro fourth ho khan tinge in fiat the tinge ron join nan fourth sem how in group a hanga te kom velo o mem pema MCA fourth sem a hian o lo pos ni mo le okay, so we have to start the I already explained the different types of this information system security. First, we have to start from the basic fundamentals and computer network. I hope that you already learned the concept of the computer networking. OSI and ISO reference model also. Did you learn before this TCP/IP stack and OSI and ISO? In Zirtem, in Sherong Tuang Trong, ka class ka chen ka chu ka lak to ho te tlat Trong, ang lo ho ka. Industrial training te khan Trong. Intel to hom Trong he hui sun in Sheve kang Trong. So ito nungai em. Hello? Okay. Okay, let's start from this syllabus. Introduction to the ISO and TCP IP stack. And here we have this introduction to ISO and TCP IP stack. What is the open system interconnections? This is developed by the ISO, International Organizations of Standardizations, in the year 1984. It is a 7-layer architectures in which layers having specific functionalities to perform. All the 7 layers work collaboratively to transmit the data from one person to another's across the global or the internet to the internet or to the satellite or any other means of communications from to transmit the data from one source to another, one system to another. So these are the things in this ISO and OSI reference models. So in the OSI reference models, in the layer 7s, we have 7 layers. The first layer is the physical layers. Okay, physical layers, that physical layers, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Okay, these are the layers under this OSI 7 layers. Okay, ISO OSI 7 layers. So below this we have a physical data network. In these physical data networks we have physical hardware layers. So this hardware layers, it comes 4 layers, physical data and network layers in the hardware layers. And here the heart of the OSI is the transport layer. This transport layer concerned about the transmissions from one to another destinations without errors and error free and error corrections and synchronizations. All these things comes under these transport layers. And the top 3 layers, we can say that these are software layers, session layer, presentation layers, and then application layers. Okay, these are the things under this OSI reference models. Okay, OSI reference models. So in the sender side, we send the data from the one computer to another, that it transmit the data. Okay, it transmit the data from one source to another's. So how it's doing? How it's doing? It's transmit start from the application layer bottom down to the layer 1 physical layers from the transmitting side. Okay, from the transmitting side, application layer, it start from the application layer down to the physical network. Okay, down to the physical network. At the receiving end, it start from the physical layer and up to the application layer. Let's see the flow of this OSI reference model. If you send the WhatsApp message, then you have to open the application layers. What is the application layer of WhatsApp? Then you have to click the WhatsApp applications. Then you have to type the text on the chat box and then send it. That this is the applications. Okay, application platform. Then it's doing some necessary things like presentations, and you have to present in a different some forms, and it maintain the sessions. When you open the applications, then it's maintain the sessions, then it's maintain the sessions, and all this. Its senders start from the application down to the physical layers. Okay, application to the physical layers. So it start the applications, and it's represent the data. Okay, it's represent the data in different form, and it's maintain the sessions. and transmit the data to the source to the destinations. It's maintain the security and then the duplicacy and also the error things is maintained in this. And down to this network hardware layers, the network maintain this IP address and all, and security, some security, error free, all these things. And in the data link layers, that is maintain the physical address and the error corrections and all these things. And down below we have in this network layer we have informations like packet, okay, packet transmitted. In the transport layers, it's maintain the segmentations. It segment the data, then it's hand over to the network layers. It's convert this segment into the IP packets. Then all those IP packets hand over to this data link layers is maintained in the frame. Okay, all those frame converted into the binary stream, bit by bit, transmit in the physical layers. This is called the bit stream. Okay, binary, bit by bit. So these are the flow of this ISO reference model. So at the receiving end, it receives data from this first layer, physical layer, and it goes up step by step. Then you receive the message, okay, of this, and let's see step by step of this working of the layer. Physical layer, I already explained that this physical layer, it's responsible for the actual physical connections between the devices. So physical connections and physical connectivity of the network devices. A physical layer contains informations in the form of bits. Okay, it transmits bit by bit. It is responsible for transmitting individual bit from one node to the next. When receiving data, this layer will get the signal received and convert into the zeros and one and send them into the data link layer. So this is the physical layers and send them to the data link layer. Okay, data link layers which will put the frame together. So the function of the physical layers are the bit synchronizations. What is the bit synchronizations? If you transmit the data from the source to the destinations, then we need a synchronization bit. Okay, a bit, the clock, same clock is needed from sending to receiving the data. Okay, it's send and receive the data. So bit synchronization is required, and also bit rate controller is required. How many data you can transmit in a second or in a minute or in hours. So this is maintained by the physical layers, that bit rate control. And also is needed to maintain the physical topology, how we are going to connect the devices in the topology, star or bus or mesh or any other topologies. So physical layer specifies the way in which the different device node are arranged in the network, how we are going to arrange the node or the network devices in the physical topology. This is maintained by the physical layer. And transmission mode. Transmission mode also maintained by the physical layers. What are the transmission modes? In this transmission mode, we have three types of mode: simplex, half duplex, and full duplex. These are the transmission mode under this physical layer. Simplex means one-way communications. It transmits only in one directions, not both sides. Half duplex means we can transmit in the both directions, but not at the same time. And the full duplex, we can transmit both sides, but at the same time. So this is the three mode of transmissions. And also in this physical layers, it's maintained as hub routers, repeater, modem cables, all these things maintained in this. And network layer, data link layer, physical layer, also known as the lower layer of the hardware layer. So these three layer 1, 2, 3 is called the lower layer or the hardware layer. So these are the things, physical layer. And then the layer, let's go to the layer number 2, data link layer, DLL, layer 2, L2. What is the responsible of this? DLL, node to node delivery of the message. Node to node means computer to computers or tablet to computers. So node is the terminations. Okay, data link layer is responsible for the node to node delivery of the message. The main function of this layer is to make sure that transfer in error free or node to node, or node to another's, one node to another's. So without errors, it's needed to transmit the data over the physical layers. When a packet arrives in the network, it is responsible of DLL to transmit it to the host using the MAC address. So here is very clear that data link layer transmit the data from node to node, from one node to another's with the error free. But if you transmit the data, then there's lots of computers are there in the network. How to identify those network? We have to identify by using the address. Okay, we have to identify by using the address. Each and every computer having an address. You already know, you already learned in this in your bachelor course also. Without addressing that, we cannot transfer the data in a network. There's lots and lots of computers in the network. In the internet, there are trillions and billions of networking enabled device node are there. So how to identify those things? We have to identify by using the address. In these network enabled devices, we have two types of addressing system. One is the physical address, one is the logical address, we can say. This physical address is named by using this MAC address, and logical address we have IP addresses. So MAC address, media access control address, this is assigned during the time of the manufacturing of the node network device. So we cannot simply say computer or laptop or mobile phones. There are lots and lots of network enabled device node. So during the manufacturing, that's it burned the MAC address. This is hexadecimal number. So when a packet arrives in the network, it is responsible of the LL to transmit it the host using its MAC address. So transmit using this MAC address. Okay, it's very clear, this one. And DLL divided into the two sublayers. Let's see this local link controller LLC and media access controller MAC address. Okay, so packet received from the network layer is further divided into frame depending on the frame size of the NIC, network interface card. Packet received from the network layer, upper layer, layer 3, is divided into frame. So from the upper layer is received the packet. Okay, packet. If we say packet, this is called the network layer. If we say frame, this is called the data link layer. Okay, packet received from the upper layer, network layers, and divided into a frame. So it's divided into a smaller frame. These frames depend on the network interface card. Why? Depend on the network interface card. So this data link layer needed to send the data via physical layer. Okay, physical layer is the network interface card. So we need to have the actual size of this frame with the NIC. Without this, it's not possible to transmit the data. Upper layer, network layer, doesn't know the network interface card, the capacity, okay, PDU, all these things doesn't know by the MTU, okay, maximum transfer unit, doesn't know by this network layer. Okay, network layer maintain the packet size only. So this is divided by the data link layer based on the NIC. Okay, DLL also encapsulate the sender and receiver MAC address in the header. So each and every frame having the informations, you can say this information is called the header. Okay, header contain the address, okay, address of the sender and receiver. The receiver MAC address is obtained by placing the ARP. Okay, we are going to learn this ARP also, address resolution protocol, using this ARP request onto the we're asking who has that IP address, and the destination host will reply with the MAC address. So these are the requests maintained by the MAC address with the receivers. So under this function of the DLL, data link layer, framing is very clear. Data received from the upper layer, network layer, and it's divided into a smaller frame. So this is done by the data link layer, DLL. Okay, it's provide a way to send and receiver the bits that are meaningful to the receiver. This can be accomplished by the attaching special bit pattern at the beginning and at the end of frame. So this is the header. Okay, trailing and headers. Okay. Physical addressing, this is also important. Using ARP, it's maintain the address of the physical layers. Okay, make address and error control. Data link layer provide the mechanisms of error control in which is detect and retransmit damage or loss. So there are some mechanism to control the to control this error in the data link layer. There are some mechanism to detect the error and retransmit mechanisms or loss of RAM. There are some mechanism to transmit the error free. Okay, in the transmission. So error control mechanisms also there in this DLL, and also is maintain the flow control also in between the sender and receiving. There are some acknowledgement mechanisms and transmit mechanisms. Okay, and access control also there. Packet deliver is referred to as frame in the data link layer. Data link layer is handled by this NIC and device driver or host machines. Switch bridge are the data link layer devices. Switch bridge and other things, devices comes under this. Okay, then let's move on to the network layers. That network layer works for the transmission of data from one host to another located in the network. So transmission of data is work under this transmission of data. It transmit the bit by bit. It's work. If we transmit the data from one computer to another, that network layer takes some responsibility. Transmission of data from one host to another is located in a different network. Different network means not in the same network, not in the same LAN, you can say. Different network means outside internet, you can say, outside the network. If we are going outside the network, so if we are in the same LAN, that data link layer is enough to transmit the data. But if it's needed to go out from our local network, then it's intervene the network layer for transferring the data. So it's also take care of packet routing. So it's routing the packet. Selection of the short path to the transmit the packet. From the number of routes available, the sender and receiver IP packets are placed in the headers by the network layers. So what are the functions of this network layer are routings. So routing is very important if it goes to the different network. The network layer protocols determines which route is suitable from the source to the destinations. These functions of the network layer is known as routing. So in the different networks, so to interconnect with this, we need the routers. So routing is very important to transmit the data from one to another network. So if we say the data link layer, then this is the same network length. But if it goes out to this different network, then it's need the routing. Okay. So this is the one of the function of this network layer routing. And logical addressings. I already explained. IP addressing, this come under this. IP address comes under this network layer, and segment in the network layer is referred to as packet. Okay. Segmentations done in this transport layer. Different types of segments are there. So if you transmit the video, large video, 1 GB of video, then transport layer divided into small pieces. This is called a segment. Okay, it slices down into segments. Then if it goes to the network layers, then it's called this packet. Okay. Network layer is implemented by the network devices such as router. So router is very important in this network layer, layer 3. Let's move on to this transport layer. Transport layer provides services to applications layer and takes services from the network layers. So it's take the information from the upper layer, transport layer, and it's give the services to the network layer. Data is transport transport layer is referred to as segments. I already explained that. Network layer, we say the packets, but in the top upper layer, then this is called the segment. It's responsible for the end-to-end delivery of the complete message. So end-to-end delivery means node to node from one source to the destination. In between this, there's lots and lots of network routings, or maybe the switches, network devices, you can say, physical layer, physical transmissions. But the responsibility of this transport layer is to transmit the data from the source to the destinations. It doesn't care about the in-between network. Okay. The transport layer also provides the acknowledgement of the successful data transmissions and retransmit the data in an error is found. So this is the end-to-end, we can say end-to-end data transmissions. If there are some error, mechanisms is retransmission mechanism is there. So the lower level, we say this network layer, data link layer, all this also having the mechanism to transmit, but this is only in the network area, retransmissions, error corrections. In between the routers or in between the switch and switch or something like this, that if there's some error in the frame, then it will transmit it. If there's some error in the packet, then there are mechanisms to transmit it inside the network. Okay, but if there's some error in the end-to-end from my computer to the Google server or something like this, if there's some error, that this is done by the transport layer end-to-end. Okay, end-to-end, and network is different. At the center side, the transport layer receives the format data from the upper layer, perform segmentations and implement flow control to ensure proper data transmission. So transport layer receives data from the upper layer. This is called the we can say application layer. Okay, let's refer to this TCP/IP application layer. This application layer is the combination of application layer, session layer, and presentation layer. There is no issue here. So transport layer receive the data, receive the formatted data. So all the users' data are formatted, we transform into some data. Then this is from the upper layer received by this transport layer, perform segmentations and also implement flow and error control to ensure data transmission. Segmentations means segment means those data are chop it down, slice it down into some block of information. It's called the segmentations. And also implemented flow and error control to ensure proper data transmissions. It's also added the source and destination ports. So very important, this one in this transport layer. What is the port? Port number. Port means we have a physical port in the computer or any node devices like USB port, VGA port, power port, all these are the physical port. But apart from this, we have a logical port. In this logical port, you are connected your device to Wi-Fi. Then it's maintain the port also. If you are connected with the physical connections like a LAN cable, UTP cables, then also it's having the physical or logical port. In this logical ports, we have a 65535 port are there. So all these ports are used for handling the transmission of data. So there are some common port: HTTP port, FTP port, email port. There's lots of standard open port are there. If we say port 80, this is HTTP transactions, and if we say 43, this is HTTPS. If we say FTP, then port 21 and 20. So those are the logical port. So using this logical port, it transmits the data. If you browse the internet through this HTTP or HTTPS, port 80 and 443 are the important port to transmit the data. But hackers cannot use those things. It's transmit only the HTML information, hypertext information only. So using this port, it transmits the data. So this is handled by the transport layer. It's also added source and destination port number in the header and forward segmented data to the network layer. So this port based transmission is there in the transport layer. So you have to remember this one. Generally, the destination port number is configured either by default or manual. For example, when a web applications makes a request to the web server, is typically used, so I already explained, port number 80. At the receiver side, transport layer read the port number from each headers and forward the data in which has received the to the respective applications. It also performs sequencing and reassembling of the segment of data. So at the receiver side, transmitting side, I already explained, port assign, segmentation, flow control, all these things done by the transport. But at the end, what is doing by the transport layer? It receives the data from the port, okay, from the port at the receiving side. The responsibility is to perform sequencing and reassembling of the segmented data. At the transmitting side, the data received from the application layer, upper layer, it's divided into a smaller size. This is called the segmentations, okay. So sequencing, it is sequencing the number also. But at the receiving end, it reassembled to the original data. This is called reassembling of the segmented data. The function of the transport layer is the segmentation and reassembles clear. And service point addressing is clear. This one, port address and all. And also provided the services, okay, transport connection oriented services. It is the three-phase process, which is include the connection establishment, data transfer, and termination and connection. This transport layer is a reliable connections, okay, and is stable and reliable. Before transmitting the data, before the actual transmission of data, it's create a connection first. Let's say before talking, if you want to talk to your friends or mom or dad or relatives through a mobile phones, first you have to maintain the connections. Means you have to open the dialer, you have to dial the number, then it dialing. So this is the connection establishment. So it's ringing the phone, you receive the dial tone, then it pick up by your target mobile phones, Then you can do some conversations. This is data transmissions. You are talking, chit chatting, and after completing this one you have to hang up the connections. Okay, you have to stop the connection. This is the termination and disconnections. In this type of connections, this is responsible, that's responsibility of three-phase connections, three-way handshaking also we can say in the transport layer. So in this type of transmission, the receiving data sends and acknowledgement back to the resource after packet or groups of packet is received. This type of transmissions is called reliable and secure connection. So the connections less services in this phase it is a one phase process is called data transfer. This type of transmissions the receiver does not acknowledge receipt and packet. This approach allows for much faster communications between devices. Connection oriented service is more reliable the connection less services. Okay, connection oriented is more reliable than connection less services. So this transport layers is called the connection oriented services. Why? It's maintain the first it's create the connections and transmit the data and terminate the connection. So you can say this is secure, reliable and connection oriented services. Data in the transport layer is called the segment. So it's called the segment. Network layer, packet, data link layer, frame. So transport layer is operated by these operating systems. It is a part of the operating system communicate with this application layer by making system call. Okay, transport layer also a part of the OSI reference model. So it's very important. So well done up to this.